How's it going, everyone? Welcome, Eulio Gonzalez here. So, today let's going to explore now about the Git, specifically what is a merge and rebase, so we can now understand that concept. And if you need to explain that to somebody else, you can do that in the most meaningful way possible. So, this is a course that is taught by, let me show you quickly. You got it? This is a course taught by the Prime G, a software engineer that is currently working at Netflix. And the goal of this is to understand now what is the value proposition of Git. And we have now a mental model of how the things work. So we know is the inner mechanism of how this stuff works. So it is a pretty short course. It's not that long. So far we are currently now here. To make a quick recap of how do we get here, this Git tool, which is a distributed version control system, which is a fancy way to say, hey, I have a local copy of the entire application that somebody is hosting, that usually a server, okay, where I can apply my change to this local copy, and therefore once that is done, I can submit them to the server. And not only that, there is a lot of contributors that can do the same for that. So when it comes to now is trying to solve particular issues, that is when we're going to talk about is the branching, merging, and rebasing. But for that, a little bit of history, and then the architecture and this fundamental concept, as well as the initialization process. So first, this tool was created by Linux Torvald, where he is so brilliant that so he developed this tool so we as mere mortals can just at least be smart as he is in terms of the ability that he has to hold the entire Linux kernel on his head. That is pretty effed up. So because of that, now with Git, we have now this ability to keep track is not only state change, but we can recreate the entire repository or the entire project from one commit. And this is why we're looking at this particular concept and the architecture of Git. So Git has the porcelain and plumbing commands. Most of the time we're gonna look at the or uses the porcelain commands, and then we're gonna dive deep into the plumbing so we can see how Git data structure works. And that's fantastic, because once you develop this notion of how the things actually is going on, and you have now this mental images model, then suddenly you know what's going on. That, and when it comes to solve any issue, specifically merging or rebasing, right, and conflict resolutions, so we know what to do. So the Git has over 140 commands, commands. So we're not going to dive deep into all of them. We just use is this Pareto principle of say, hey, we're gonna look at the 20% of the command that get 80% of the outcomes or the results in our daily jobs. So first we look at the concept like commit. So what is a repo? Which is the Git project. It is the Git project. It is the way. It is a project that is being tracked by Git. We also have the commit, which now contains the entire state of the application. It's important to know the entire state of the application that we can now recreate to develop or launch that locally, right? Or even in production. And also, so this is not storing as any diff, as we might think. and also the different staging areas or different areas that now get used as a way to now keep track all of these elements. So you have now the track area, the stage area or the index area, as well as uh, the track area, right? So once you now looking at these different places, which is also known as the work tree, the working tree, or the working tree, which is the working directory where you're currently at. Okay, then we look at how can we initialize Git using the Git init, what is doing behind the scenes, how can we now configure is Git in a way that, well, all we can define is who is committing this through the user.name or the user.email, and also some additional configurations such as the Git diff, the Git sections, where you can now add some additional informations on the configurations that perhaps you can use for some internal reasons. Okay, and then we look now at how can we now is creating is our first commit or the Git process. Okay, so now that you apply some change to your repo, so once you initialize the repo and then you apply some different change to your repo, okay, now it is time to add those changes to the index or to the working tree, and then once you are sure that this is the last commit or the last changes, then you're gonna commit to that, and therefore you're going to now or you're telling to Git anytime that you commit those changes to say, hey Git, I want you to now is create this SHA or this 40 character length alphanumeric that will have now a pointer, okay, or this now is pointing to the file and also the content of the file. So because every time you create a commit, what it's doing is using is the content of the file that you change, as well as the author name, the time, and all of this data that it combined it, or this is an amalgamation of all of these different data that allow you to create this unique commit, okay, where now this is a node on the Git, or in other words, the way how now Git see things is through this acyclic graph. Or in other words, this is the way of how this is how the data structure is organized. Okay, so it is in an acyclic graph, and we call it an acyclic graph because it doesn't contain any loop, and you can have, so one node can have is multiple parents. So so this commit, so anytime that you create a first commit that is a node on the acyclic graph, this is something that you can now or Git add some information to this, one of the tree, the commit, as well as the author. So the tree, the easiest way to think of this is, well, let me actually show you this, and then we can move on to what we really care about in today's video. Okay. Git essentials. There you got it. So Git, it create anytime that you commit something, all right, we can inspect now with the Git log tool, utility tool, which is a powerful tool. We say, hey, I want to look at the graph, as well as I want to look at the Git log graph and Git log decorates. So then you can start to see is all of these different commit that's going on. So as you can see, this is part of the node, this is another node, and this is the content, or this the commit message. All right, so anytime that you have access to this, the first 7 characters actually are the relevant. So if you want to know what a commit is, by saying git cat file -b, okay, it has now this information of the tree, the author, and the committer. And the easiest way to think about this, yeah. So, and the easiest way to think about this tree is that this is a folder structure, right? Where now it has a commit. Remember, the first 7 characters of this commit are the useful to actually now inspect that. You can say, hey, I want to know what that commit contains, all right? And as you can see, it say, hey, this is now some random number here, followed by the blob, which is a binary large object, which is now the reference of this content, or this is the reference of this file, all right? This is the commit, okay? This is another commit that is now pointing to the content. Let me actually show you this. That is actually pointing to the content of the README, which is in our case A. So we make this single letters is just as a way to make it easy for us to follow what's going on behind the scenes. But once we know what Git is doing every time that we create a commit, which is essentially to know that, we'll also look at how can we now branch off, or how can we create now a different history or a different staging or applications where we're going to add now different changes and what's going on when we do that. So in our case, we have now git branch here, and we already have several branches. And a branch is just a commit. It's a reference to a commit that you did at some point in the past. So for example, if you want to know how Git is actually looking at this, or where is this information located, by inspecting on the Git file, all right, you can see that now we have several of this commit, all right, and this commit has the information of all of the commit that we have done in the past, all right, and also on the ref is where it's now adding this different branches. If you want to inspect what is the content of this, you can say, hey, concatenate the output of the, for example, trunk merge foo, and this contains now a SHA. This that if you inspect that, okay, and then you say, hey, I want to know is this, it's a look at this. I have now the content that this is telling me, hey, I have now a commit that is 3 parent, it has 2 parent, the author and commit, and what it means by this is that this is now a merge commit. What is a merge commit? Glad you asked. So because this is part of the branching strategy and in conflict resolution strategy, so we have now merge and rebase. So merge is when at some point that branch has 2 different history. It's an attempt to combine them based on a best common ancestor, or aka the base commit, which is where is the point at where in time it is the point at which now that branch diverge. Okay, so that's now is the best common ancestor. So once it locates that, the merge is trying to attempt to play all of these commits and then create a merge that allows you to decide if, well, console this conflict resolution and all that kind of stuff, right? And there are two type of experience in Merge. So you have now is the message input, where it tells you, hey, even though that there is no conflict, I need you to create is a merge commit, one, and the other is when it do a fast forward. So for the first option, this is now saying, hey, what happened when that, what happened what happened when you're merging and it prompts you a command, or it prompts you to create this merge commit, is because at some point in the future, at some point in the past, this branch has different histories. Okay, so a good way to illustrate that, and I think this is very important. That's where we use all of this kind of stuff. A way to illustrate that is, let me show you this. Let me see. Oh, I didn't have that? No way. No way. Well, in any case, oh my god, I didn't have that. Anyway, let me show you here, like this. So if you have now two branches that at some point they have different history, this is when now Git say, hey, let me show you this input prompt to create now a merge commit, where this merge commit will have now is the commit, which contains the stage of the repo plus the author plus the names and the time, and the commit from the patterns when you now merge, or the branches where you now merge those. The tip of those, the tip branch commit, the tip of the branch commit that is now merging and creating a new one. But the TLDR of this is that merge is something that you most of the time you don't want to use this, and they have this use case, something that the prime mentioned. Okay, so far so good, because now with that, all right, we also look at the rebase and what rebase is allowing to do. So with rebase, the TLDR is that it allows to rewrite, or it allows to rewrite the history of our branch, of our current reality, right? As opposed to test the reality that, as opposed to test your reality with some previous reality that is no longer the true. Or in other words, it allows you to now is move the needle, or move, yeah, it allows you to now, with rebase, it allows you to move the needle from this branch that you want to merge in, okay, into the tip of that branch. So by moving that into the tip of that branch that you want to rebase, okay, and even though the name it tells you is what it is doing behind the scenes, so it's now is as if the merge is giving you this idea, is the merge is giving you the idea of having the known best common ancestor, and from there now play each one of them to create a merge commit with all of this, and then you're going to resolve all of that. So instead of doing that, it say, I'm going to now look at the common best ancestor, all right? I'm gonna store now that branch that you want to rebase in a temporary folder, okay? And then I'm going to move the commit, I'm gonna create a new commit, a new reference to the tip of that branch that you want to rebase, okay? And then I'm going to play one by one from the temporary branch, one by one, all of this commit at the tip of the branch that you want to rebase, which is exactly what it's doing here, right? So we also look at this, and this is very, very powerful stuff. So the question is that when you want to use this, you know, because this not only give you is that this not only give you the ability to change the history of your commit, okay, or the history of your Git history, but also is that you can now handle conflicts individually for each commit, right? So maintaining the original authorship information. So with that, I want to know what is the main use case when you want to use this Git rebase and merge.
There we go. We'll create the new branch, foo rebase trunk, and then I'm going to go git rebase trunk.
Exactly. And also when you're going to do this, the merge or rebase, what it's going to do is, hey, I'm going to take now is the current branch. In the case of merge, I'm going to take now the current branch and the branch that I'm going to merge, and then I'm going to look at the known best common ancestor, and if at the target branch is at the tip of the branch, aka that there is no any commit or new commits, then I'm going to do a fast forward. If it's not, I'm going to create a new merge commit with these new changes. And you're going to see why this can pollute a lot of the this can pollute a lot of the Git logs, because especially if you're doing a lot of merging from that, can be quite cumbersome. So whereas with rebase, okay, you say, hey, this is the branch that I want to now is move the needle or rebase to the tip of the target branch. So in other words, what it's doing is we do the foo rebase trunk like this. This is the foo rebase trunk that I want to move to the trunk and apply all of these changes on top of that.
All right, we've rebased. So what happened? Well, let's look at the log. Git log.
So if we go now to the log, I think I already did that. So git log graph and decorate, because the branch is foo rebase trunk. Let me actually show you this. Foo rebase trunk. That's right. So foo rebase trunk. But I didn't create that. Yeah, then you got it. So I rebase the foo rebase trunk to the foo position. So what is the git log graph decorate of the foo is this one, but I think I didn't. Foo rebase trunk. I think I didn't apply that, because git log one line trunk, git log one line trunk. Okay.
One line. Look at.
Oh, exactly. So if I now going to say is foo rebase, which is changing to the git switch foo rebase, okay, and here I'm going to do a rebase with So I want to do is the rebase with this. All right. I want to do the rebase of trunk. All right. In other words, it's like moving this changes to the top of this, and then apply that to the food rebase trunk. But it's in this branch that I want to do this. Okay. So if I say, hey, I want to apply this, I want to rebase this branch with this another branch. In other words, it's the base branch, the current branch, git rebase with trunk, successfully rebase to upload. So what does it mean is that, well, if you take a look now, git log one line, foo rebase, all right, there you got it. So this current branch is like we updated to that with this change, and as you can see now, foo rebase that has is the C and B change. So we just now we now is apply those changes to the trunk and bar. All right, on top of the trunk, and also that is the same as bar. So you have to be careful of that.
So what happened? Well, let's look at the log. Git log, one line, look at what we see. We see trunk. But we also see our two commits that differed from trunk now after Y. We now have history that is linear. So now you see that trunk, which contained bar as our last merge, is now the base for foo rebase trunk. In other words, foo is no longer diverging from trunk. It's now linearly walking the history forward, which means we can fast forward merge if we want to. So there are some pros. Obviously, you get a clean history with no merge commits. So as if you use git log to kind of look through things, if you want to walk backwards through changes, there's just significantly less kind of commits to have to go through. The cons obviously are that it alters branch history. And when you alter branch history, if you have the same branch on another repo, you then have a problem because you have two branches named the same thing. The cons obviously are that it significantly less kind of commits to have to go through. The cons obviously are that it alters, which means we can fast forward merge if we want to. So there are some pros. Obviously, you get a clean history with no merge commits. So as if you use git log to kind of look through things, if you want to walk backwards through changes, there's just significantly less kind of commits. Obviously, you get a clean history with no merge commits. So as if you use git log to kind of look through things, if you want to walk backwards through changes, there's just significantly less kind of commits to have to go through. The cons obviously are that it alters branch history. And when you alter branch history, if you have the same branch on another repo, you then have a problem because you have two branches named the same thing with two different histories. And so this is typically where you see that git push force because you want to forcefully tell the other repo, I know what foo has, and my version of foo is more correct than yours. So you need to update everything. All right, so some cautionary words. Never change the history of a public branch. I believe Mark over there, Mr. CEO, actually has done that once before, and it's a mega pain. It's a super pain. Don't ever do that. So typically what you'll see is always merge on public branches, rebase on private branches. So you have some changes, you want to make sure they actually work with the latest part of your, whatever you're working on. You can then rebase it forward, run your test, run whatever. Everything works. If you have a conflict, you're gonna have to resolve it. That way you have your private branch being
exactly. Or tips here. Merge on public branches, rebase on private branches. Okay.
Altered in history, but your public branch never changes history. The moment you do that, it breaks everybody. Everybody breaks the moment you change public history. So don't ever do that for any reason. There's a lot more, but we need some more foundational knowledge before we go.
Exactly. So the moment you because you're rewriting the history and you're breaking for everybody because you are rebasing, you're changing the history, and anytime that wants to submit that, you're breaking for everybody. The moment you do a rebase in a public branch, it breaks everybody. merge on public branch, and rebase on private one. French toast. Anyway, so the moment you do a rebase in public, it breaks for everybody, because you are now is interest, because now you are is changing the history, which means now they need to sync with that. And also, for example, if you have here a different git, okay, if you have now a rebase here, so if you have now two branches that have the same commit, and then you update the new one, this is the way of saying, hey, this new branch with this new rebase is now the source of truth. All right, I have the correct version of the application, and therefore now I can do that.
Over it. So we kind of have a nice little base here. Now you know branches, public. You have actually worked with the latest part of your, typically what you'll see is always merge of a public. I know what foo has, and my version of foo is more correct than yours. So you need to update everything. All right, so some caution, because you want to force other repo, you then have commits to have to go through. The cons obviously are that it alters branch history. And when you alter branch history, if you have the same branch on another repo,
so if you have the same branch on another repo, another project that Git is being tracked, okay. So if you have the same branch on another repo, because you have two branches,
you then have a problem because you have two branches.
You then have a problem because you have two branches with the same history,
named the same thing with two different histories.
Because you have now two branches naming the same thing, with two different histories. Okay.
So this is typically where you see that git push force, because you want to forcefully tell the other repo, I know what foo has, and my version of foo is more correct than yours. So you need to update everything. All right, so some cautionary words: never change the history of a public branch. I believe Mark over there, Mr. CEO, actually has done that once before, and it's a mega pain. It's a super pain. Don't ever do that. So typically, what you'll see is always merge on public branches, rebase on private branches. So you have some changes. You want to make sure they actually work with the latest part of your, whatever you're working on. You can then rebase it forward, run your tests, run whatever. Everything works. If you have a conflict, you're going to have to resolve it. That way you have your private branch being altered in history, but your public branch never changes history. The moment you do that, it breaks everybody. Yeah. Everybody breaks the moment you change the public history. So don't ever do that for any reason. There's a lot more, but we need some more foundational knowledge before we go over it. So we kind of have a nice little base here. Now you know branches, merging, rebase. You kind of get how they work. You understand how commits work. You actually understand that it is the storage point of the entire repo per commit, but it's efficiently stored, so it's not a waste of space.
Exactly.
This is also why whenever you're downloading a Git repo that is has a long history, it takes a while because it's literally downloading every single change.
So now we know why when you are downloading a Git repo, it might take quite amount of time to do it, because it is downloading the entire state of the application and also the branch.
Possible. This is also why whenever you're downloading a Git repo that is has a long history, it takes a while because
because it is unloading the entire state of the application and it is history.
It's literally downloading every single change possible because it needs to be able to reconstruct the repo at any one time. That's also why if you do a git clone and use like depth 1, I believe is the proper option, it'll actually just clone it down with only the last commit, which will contain the entire repo.
Okay, it makes a lot because it is unloaded the entire state of your application and history. Uh, that's why we use git clone def one. Mm. Mm-hmm. Okay. Git git clone.
That time. That's also why if you do a git clone and use like depth1.
Exactly. If you use git clone uh, def1 is now bringing it.
I believe is the proper option. It will actually just clone it down with only the last commit, which will contain the entire repo.
Mm-hmm. It will give you is only the last commit, which will contain the last repo. That's interesting. But again, we already know what is going with the basics of Git, all right? Of the architecture of Git, the porcelain and the palming command, also the idea of all of these concepts like repo, commit, different areas like the staging or the on track, the staging, and the track, as well as the git log and the working tree directory and what's going on at each different place to your files, and how you can initialize now Git, what's going on behind the scenes, how you can now configure Git, how you can add property to your Git for some sort of utility data you might want to use later on, and what's going on when you create now a commit under the folder structure. We also inspect the folder structures, and when it comes to create now a branch, what's going on behind the scenes, because this is just a commit that you did in the past that now Git has a reference under the ref folder. That store is now the name of the branch as well as the SHA, the secure hashing algorithm of 40 length character, alphanumeric, 40 alphanumeric length character. And it does this in a very efficient way to have now the entire state of your application, because this is a commit. We look at the anatomy of the commit that had the tree, the directory, as well as the header tree, the author, the committer, and also the parent, if it's now, of course, a commit in the cyclic graph, or it can have multiple parents if this is part of a merge commit, which this merge commit is one of the strategies that you can do to actually now merge and attempts to combine different histories of a series of chain that you have done, series commit, series of state of your applications, by looking at the most common, the best common ancestor known as the base merge, and therefore now create a commit. So because if you have now different history that you want to merge, Git will ask you to prompt some inputs on the merge commit, because what it's doing is looking at that best common ancestor and replay each one of them and tell you is where do you have any conflict here. Whereas with another strategy, when it comes to have a linear history, because the problem with merge is that you have now all of this merge conflict or merge commit that now create is it is it can become quite hard to read. Okay, if you have all of these branches merging into the main repo, and that's what we have now rebase to actually now say, hey, let's going to now keep the history liner as possible by now look at the base commit from when these two branches are diverged, okay, and then the branch that you want to move, or in other words the branch that you want to rebase, copy that in a temporary file, then now create a commit that puts that branch on the top of that, which is the branch that you are currently at. In our case, the full rebase trunk, the current branch that you're currently at, when you apply rebase, is that you're telling to move the pointer to that branch, to the tip of that another branch, and then replay all of this commit. All right, and if there any conflict, well, you can solve each individual commit. This is great for private repos, makes a lot of sense. But for public repos, if you change the history of the public repo, now it is a problematic. Okay, it is a problem. You have a problem. You and the other people that are collaborating, they have a problem. So that's now that we know what's going on behind the scenes, and when you are downloading all of that, and therefore is something that you say, all right, now let's get into. So when you clone a repo, now you know what's going on, and if that repo has a long history, okay, it will take a while to download that. That's why when you clone a repo, you use the depth one. I think that is the correct one. I'm going to check that out later on. But you have now a configuration or a flag to say, hey Git, don't give me the entire history, because it contains a lot of this. So I will need to download all of these different previous state of the application. So I don't need that. Give me just is the current state of the app. That makes a lot of sense. Oh my God. That makes a lot of sense. Mm-hmm.
We're going to talk about head. You've seen it already. It's been in the logs. You see this constant head dash, whatever branch name. It probably is a little bit confusing. You should rarely use it if you don't if you don't have to. You should try not to play with it. You know, it's just it always causes so many problems the moment you start checking things out. But if you know how to use it, it's fantastic. I use it all the time for interactive rebasing. I'll do like a head tilde 6. I'm able to squash everything. It's fantastic, but it can also be a pain. So throughout this course, you'll see this. So what is head? We can do some experimenting. So what I want you to do is I want you to check out trunk.
Okay.
And then I want you to execute log one line.
Check out trunk and get log
add a little
one
line there. You'll see. Head points to trunk.
Exactly.
Everyone should see that. Let's do it again. I want you to check out foo, and then I want you to do another get log one line. So get check out foo, get log one line. Again, head's now pointing to foo. So it's like every time we change branches, notice that head's pointing to whatever branch we have checked out.
Mm-hmm.
Okay, this is important.
Mm-hmm. Let me see if that is true. Okay, so git switch to foo, and then we say git log one line. We have now our head pointing to that. Okay, to foo. So we say, hey, now I want to move to bar, and if I want to look at log, so now hey, head is now pointing to Z. Okay, and if I say git switch to trunk, okay, I can say git branch, say git log one line, and there you get it. Okay, okay, so anytime that you change your branch, so now head is pointing to
Go check out the Git folder and tell me what head is pointing to. So if you go in here and you go ls git, you'll see that like named item is just a top level item in Git. So if I cat git.
Exactly. So if I want to get access to Git head, it has now a text that say, hey, it's a reference to the head's trunk. Oh, so the head is now a reference to the red head's trunk. And if you want to know what that it contains, all right, the git dot ref dot heads dot trunk is now a commit to that. It contains the entire state of the repo.
Git slash head. Oh my goodness, just autocomplete. You'll see right here, it's a ref to foo. That's all it is. It's just this thing that exists right there. It's just a pointer to whatever you're currently using. It's really nice. Like once you see that it's
so head is a pointer to whatever you're using.
just not that magical. That means if I go cat refs or git refs heads foo, you'll see it's just a commit.
Exactly.
Like we're walking through starting at head all the way to the exact commit, and that means I could reconstruct the repo now that I have this commit, and we did that earlier. So we can actually go all the way from head to the exact file that we want to look at. And so this is kind of how that works. It's just good to have in your head how it works. But I have this commit, and we did that earlier. So we can actually go all the way from head to the exact file that we want to look at. And so this is kind of how that works. It's just good.
So now the head is pretty straightforward. It's not that hard.
But it can also be a pain. So throughout this course, you'll see this. So fix, I'm able to squash, start checking things. It's been in the log.
So head is whatever branch that you're currently pointing to. So head, and reflow. Okay. So head is whatever branch. So head is whatever branch that you are currently pointed to. Okay. So head is whatever branch that you are currently pointing to.
You see this constant head dash whatever branch name. It probably is a little bit confusing. You should rarely use it
So
if you
head
don't
is
like. If you don't
whatever
have to,
branch
you
that
should
you're
try not to
currently-
play with it. You know, it's just it
that
always
you're
causes so
currently
many problems the moment you start checking things out. But if you know how to use it, it's fantastic. I use it all the time for interactive rebasing. I'll do like
So
a head tilde
head
6. I'm able to squash
just
everything. It's fantastic.
contain
But it can also be a pain. So
Is a
throughout this course, you'll see this.
reference
So what is head? We can do some experimenting.
to
So what I want
the-
you to do is I want you to check out trunk,
contains
and then
a
I want you to
reference to the
execute log one
file
line.
that whole
Now add a
or
little
that
one line there. You'll see
has
head points to trunk.
file
Everyone should see that.
hole around.
Let's do it again. I want you to check out foo,
That
and then I want
says
you to do another git
that
log one
God-
line. So git check out
So
foo,
head just contains
git
a
log
reference
one
to the
line.
file that got.
Again, head's now pointing to foo. So it's
that
like every time we
has-
change branches, notice that head's pointing to whatever branch we have checked out. Okay, this is important.
So head just contains a reference to the file
Go check
that
out the git folder
has
and tell me what head is pointing to.
that has a
So you go in here and you go ls git, you'll see
commit.
that like named item is just a top level item in Git. So if I cat git slash head, oh my goodness,
reference
just autocomplete.
path
You'll see right
file
here, it's a ref to foo. That's
to
all it
the
is.
file.
It's just this thing that exists
a
right
reference
there.
file.
It's just a
It
pointer
just contains a reference
to whatever you're
path
currently
files
using. It's really
that
nice. Like
has-
once you see that it's just not that magical, that means if I go
that has a
cat
shack
refs
commit.
or git to whatever you're currently using. That's all it is. It's just this thing, just autocomplete. You'll see right here, it's a ref to foo. That's all it is. It's just this thing that exists right there. It's just a pointer to whatever you're currently using.
Mm-hmm. is a pointer to whatever branch you're currently at.
It's really nice. Like once you see that like file that we want to look at. And so this is kind of how that works. It's just good to have. That means I can resurrect the repo now that I have this commit, and we did that earlier. So we can actually go all the way from head to the exact file that we want to look at. And so this is kind of how that works. It's just good to have in your head how it works. Didn't even know that was going to come out. All right, here we go. Reflog. It's actually not a wizard's tool. It's just not. It feels magical, but it's really like it's very one-dimensional. So reflog just shows you where head's been. So.
Oh, reflog. Oh, reflog will show you where head has been. That's interesting.
Give reflog a try.
Reflog.
Oh, I just told you. I unfortunately just ruined the moment.
Reflog.
Just execute get.reflog and just look.
That's interesting. Reflog.
Look at it and see that it followed how you've changed your branch. So if I do it, if I go get reflog, you'll see that. Look at that, moving from trunk to foo, from foo rebase to trunk. You can just watch me change each one of these, and it comes with the commit shop on each one of those items. This is when I was at B. Remember when we goofed things up way earlier in the repo? You can actually see me doing like a what's it called? A reset. Like you can actually watch me do all my oopsie daisies. We redid everything right here. Look at that. So you can actually see the entire history.
Okay. See the entire history of head on this. Moving from front to trunk. And then I say I commit to B, I commit to C, moving from front to trunk. D, A, moving from trunk. Okay, this is a tracker of the head. Ref log. Okay, but of the head. Interesting. So far we have made some 30 changes, so 30 movements from that, right? Even though the merge from foo, moving from do, commit X, merge foo to that, and then the head moving from trunk to trunk. Okay, this is all what happened in trunk. Okay, followed by this, check out moving from trunk to bark, and then commit on X, and then commit on G. Okay, and then check out moving from bar to foo. And then because I switch also is doing the checkout. Okay.
History of all decisions you've made in your repo by looking at reflog. And all it is just simply the log of where you've moved. That's it. Nothing magical about it. It's very, very simple. Do you think you can find where reflog is stored in the Git folder? Is it a log? How do they store it? All right, so if I go here and I go like this, if I just ls git, you'll see, oh, look at that, there's a logs folder.
There's a logs folder.
You know, that feels pretty serendipitous, right? So what's in the old logs folder? I go here and very, very simple. Do you think you can find where reflog is stored? All it is just simply the log of where you've moved. That's it. Nothing magical about it. It's very, very simple. Do you think you can find where reflog is stored? Do you think you can? Very simple.
This one. Do you think you can find so reflog is just a log of where head has been. There is a folder called logs that actually keep tracks that.
Do you think you can find where reflog is stored in the Git folder? Is it a log? How do they store it? All right, so if I go here and I go like this, if I just ls git, you'll see, oh, look at that, there's a logs folder. You know, that feels pretty serendipitous, right? So what's in the old logs folder? Well, look at that. There's one called head. What do you think's in that file? Let's just pretend that I don't know, and let's cat it out. Huh, does that not look pretty dang familiar? Reflog is just prettifying this file. At least in its default basic usage. There's a lot of options. There's always a lot of options. In fact, you can even use getlog to create reflog with a whole bunch of options. But we're not going to do that. Just this right here is as simple as it gets. At AOL, yeah, I did AOL. For those that are laughing, I did AOL.com. I thought it was funny.
Oh my god, even though you can actually look at that, because it's pretty fine this. Because another word to say is like, hey, I want to get access to the git git logs head. All right. And look at that. This is just a way to purify this.
But we're not going to do that. At least it's and let's cat it out. Serendipitous, right? So what's in the old logs folder? Well, look at that. There's one called head. What do you think's in that file? Let's just pretend that I don't know, and let's cat it out. Huh, does that not look pretty dang familiar? Reflog is just prettifying this file.
Even now have keep
At least in its default basic usage. There's a lot of options. There's always a lot of options. In fact, you can even use getlog to create reflog with a whole bunch of options. But we're not going to do that. Just this right here is as simple as it gets. At AOL, yeah, I did AOL. For those that are laughing, I did AOL.com. I thought it was funny. It's a great email, okay? All right, solution. You can do a reflog -3, and you can actually see 3 lines of your reflog. So if you don't want the whole thing, you just want to see a little bit, you can actually give it how many lines you want. So if I go get reflog 3, I see 3. That means if I cat out my head and go tail 3, you can see the last 3. And you'll notice they kind of look, they're the same, right? You can see here moving from trunk to foo. Moving from trunk to foo. So there you go. It's inverted. The last line of the file is the first line in reflog. It just takes the file and inverts it. That is it. So there you go. Now, hopefully again, trunk to foo.
The last line of the file.
So there you go. It's inverted. The last line of the file is the first line in reflog. It just takes the file and inverts it. That is it. So there you go. Now, hopefully again, the magic is being slowly spoiled, and now the real magic happens, which is how simple Git actually is and how powerful it really is. That's where the real magic is in the use.
Yeah, actually. Head and reflog.
This will be kind of a weird task to do, but it will be fun. What I want you to do is I want you to create a branch called... This will be kind of a weird task to do, but it will be fun. What I want you to do is I want you to create a branch called Baz. I think currently we are on foo. You can create on whatever you want. It doesn't matter about the base branch you're branching off of. Why don't you create a branch, or I guess I say do it off of trunk. It really doesn't matter. But let's just for now just say create a branch off of trunk called Baz. Add one commit to Baz, and do it in a new file. Right? Don't do it in README. Do it in a new file. Switch back to trunk and then delete Baz. And then I want you to bring Baz back to life from just the SHA.
So create a new branch of trunk, call it Baz, add one commit to Baz, do it a new file called baz.md, switch back to trunk and delete Baz, git branch -d Baz from early. Can you bring back the data from the commit SHA of bar by looking at where the head has been? I can. Oh my god. So we're gonna do this. We're gonna do this exercise. Definitely. Shit. Okay. It's gonna create now a branch of trunk. Okay, create a new branch of trunk. That's what it is. So git checkout -b. Okay, and then it say, hey, call it Baz. We're gonna call it Baz. I want to create now a content there by saying echo Baz here, and concatenate the output to this baz.md. all right, I want to now git add that bash to the staging area, and then now I want to create now a commit that will now allow us to say Baz, say add baz.md, behind the scenes now it create now a new node in this acyclic graph that contain is the state of the repo at that moment, the set of change, the set of that contains the state of the repo with this new set of change at that moment, plus the author, plus the author, plus the time. Okay, and then I want to switch back to trunk. Exactly. Switch back to trunk here, okay, and delete bass here. We're gonna switch to trunk, and it's going to delete bass here from early. And the thing is that can you bring now is from the death. Delete branch bass was, even though it's telling you to do this, right? Can you bring back from the dead the commit SHA of bass? So if we do this, say git cat file with that, we already have that commit for that. Oh my God. Where, of course, we have now. So if we do is the ref log, say git ref log, to know is to say, hey, the head was at the commit bash. It doesn't tell me is the commit, but we can now inspect into the head logs to see, hey, at bash that contains now these two commits, all right, which to me is quite interesting. This is not the commit that we did here to this, moving from trunk to bash, all right. In other words, this is the branch that we create from this, okay, and then we commit that. As you can see, is pretty much that. Setting FDD AC81 is this one, and it's, we could access through that thanks to where the head has been.
And we can discuss how you do that. So first do the first three, and then we'll kind of talk more about this last one. And I'll join you. I'll go git check out trunk, git check out dash b baz, echo bazzy to baz, git add, git commit. Definitely my best work here. Git check out trunk, git branch delete, baz. Dang it. I just lost all that work, and oh, darn it, I just lost all my history too. I could have probably recovered it if I didn't control L, but now look at this. I'm up a river without a paddle, right? Well, hopefully you don't think that.
I'm on a river with one paddle, right?
I think this is a fun kind of exercise to go on. So let's first use reflog, and let's recover our SHA. So what I'll do is I'll go like this, git reflog. I know it's in the last couple, so why not just do a -5 so you don't see your entire history? And look at this. Definitely my best work. Okay, so that's the SHA. We have the SHA from that commit here. Which means what can we do with a SHA?
Well, actually is we can check out from that SHA, you know?
Look it up. Rebuild the whole repo.
We can rebuild the entire repo just from this one little tiny SHA. Right? Remember, git cat file dash p this. Look at that. It's right there.
Repo.
It's still in Git. Just because we deleted the branch did not mean we deleted what you just changed. It's in Git. The files are in the computer, as a wise man once told me. All right, problem.
The files is the computer.
Sweet knowledge of how Git plumbing works. Can you retrieve the contents of the commit using our...
Oh, even though that you delete that, it's not, you didn't delete that.
Super awesome powers to grab out baz.md. Can you do that?
Use our knowledge to how Git plumbing works to retrieve the content of a commit using this superpower.
You have the SHA. Try to get out what was in baz.md, not from your memory, but from Git.
Exactly. Well, so you can say git cat file
dash p with that. I can go into the tree. Git cat file dash p that. I can see my little baz file right there, and then I can git cat file dash p that thing, and look at that, bazzy. I recovered it walking the SHAs all the way to the exact file. So I could take this and I could cat that and I could pipe that into baz.md and then I could get status and look at that, get diff. We actually don't have anything in there because it hasn't been added. We could add that and then get diff staged. And look at that, there's Bazzy. It's a new file right here. Oh my goodness, I've just recovered it. And I feel like a hacker, right? I mean, there is actually easier ways to do this, but that was just kind of fun, right? Pure wizardry. You do this at your job, you're getting a promotion, right? Like just right off the bat, Brent, CTO, front-end masters, will just hire you as the new CTO, just doing this. All right, let's not use the internals. Is there another way? I mean, it's great flexing, right? You should always flex at work when you can, but maybe you don't have to. Is there an easier way to do this? Well, you can always just do the, unfortunately, the, here, hold on, I'll go like this, get ref log.
Get ref log?
Let me just have this thing out right here.
In chat, someone mentioned cherry pick.
Shh, chat. All right, so one thing I can do, if I really wanted that change in trunk, I could get merge just that SHA. I already have the SHA, right? I could just bring it in. Git still has the state. Boom, look at that. Baz is now in trunk. Wow, that was magical, right? We didn't have to do all that hack command stuff. We just simply needed the SHA, and then we can just merge it into trunk. Now I have Baz right there. It's just right there. Kind of interesting, right?
Yeah.
You might not have seen that one coming.
No.
So we can do that. But there is a problem with merge. What happened if there was a lot of diverging that happened? What happened if there's a bunch of commits in betwixt my trunk head and that commit? What would happen if we merged it? We'd get all that history, right? Because it's going to try to find, what does it do again? It walks back, it finds the merge base, or the best common ancestor, and then it replays all of those potentially into a third branch, and then does a merge commit if the histories have diverged. So you may not want to do all that, right? That may be kind of a pain. Maybe you just want that commit and not everything else. Well, I don't know if you know about cherry pick, probably have never even heard the term until this exact moment, but cherry pick allows you to take just one or more commits specifically. Cherry pick is fantastic. I've used this probably as one of my 20% commands. I probably have used this the most. It's just because anytime I have just that change, I don't want to merge, I just want this one diff, cherry pick it in. And it works with remotes, it's fantastic. Long as you are up to date with your remote and you have all the changes from them, you can just cherry pick a singular commit into your project if you need to. It does require your working tree to be clean. Remember, working tree is just the state of your project, everything that's been tracked by Git. So no changes to your working tree, and then you can cherry pick, and no changes to your index either. Sometimes if you have like index problems, it will say no. Index again is the staging area. Remember, it's not necessarily your working tree. So there you go.
Yeah, that your
So get cherry pick. Try if you haven't done it. See if you can cherry pick the change of Baz into trunk if you did not merge it in. So all you have to do is, of course, get cherry pick and the SHA, and it will just merge it right in. Fantastic. Oh, really? Real talk, it is like by far one of my most used commands is cherry pick. Absolutely, just has saved my bacon more than once. Because have you ever had like a change that has diverged so bad due to something, and then you just get the merge conflict is just incomprehensible. And this has happened to me, and luckily you've made some small. Have you ever had like a change that has diverged so? One of my course, get cherry pick and the SHA, and it will just merge it right in. Fantastic.
So if I do this, for example, is this git log git ref log, okay? It gave me only the 3 last one. I got now is the commit at bar, okay? The contain is the state of the application. You can say, hey, git cherry pick of the hash, and then you got it. We add now this one. Holy moly! Oh crap! So you add now. Oh my French, those guy, bro. Jesus. You can now cherry pick a commit, which is a state of the application that has this additional that has this set of chains that was previously added, and then. With the author of the name, with the author, the committer, and the time, and then you can now add that to here. Oh my God, this is really fantastic, bro.
Oh really? Real talk, it is like by far one of my most. Oh really? Real.
Holy bro. Holy bro.
real talk, it is like by far one of my most used commands is cherry pick. Absolutely, just has saved my bacon more than once. Because have you ever had like a change that has diverged so bad due to something, and then you just get the merge conflict is just incomprehensible. And this has happened to me. And luckily, you've made some small commits, and you haven't made one big commit. You're like, I'm just going to take out these two things, play them over here, and then try to rebuild the rest of it. I've been in a situation where it was.
Yeah, exactly. So that's why if you do small changes, okay, that's why if you do a small changes, you can cherry pick those commits and replace them into your own branch. Okay.
It was such a bad divergence that I the only way forward was to actually just like hand move things over, and that was with cherry pick.
Mm-hmm. That is.
Do you feel
powerful? Do you feel powerful?
Powerful now. Is your get knowledge growing? Hopefully.
Oh my
well, now we're gonna talk
God.
about remote get, right? Often we need changes.
That'll be all for this video. Take care. Bye bye.